was a little... All right, so what do we got? More of the same?
Yeah, I have my unit exam tomorrow, so it's over everything that we did yesterday, and then some calculator things, but I have all the calculator stuff figured out.
Okay.
So I have, I guess just going over more of those, like cosine squared 30 minus sine,
No,
all of
that's
those,
fine.
that would be
Let's
good.
do it, and we'll see if you can do most of it.
Yeah, perfect. So I have like a really long one,
Okay.
and it's cosine, and then in parentheses 5 pi over 12, and then cotangent, and then in parentheses 5 pi over 12. And then secant, and then in parentheses negative pi over 12. And then plus tangent, and then in parentheses negative pi over 12. And then secant, and then in parentheses 5 pi over 12.
That it?
Yep.
All right. Let's talk about one other property that we didn't talk about yesterday at all.
Okay.
And that is odd and even functions. If you'll remember from your Algebra 2, an odd function is one in which f of minus x equals minus f of x, and an even function is one in which f of minus x equals f of x. An example of an odd function is sine. An example of an even function is cosine. In fact, sine and tangent are both odd, and the only even one is cosine. Now, when I say that, clearly the reciprocals also have to be the same.
Yeah, she gave me, she wants us to memorize all of those identities.
Yeah, the only three you need to memorize is sine, tangent, and cosine, because you can figure out that the cosecant, which goes with sine, is also odd, and the cotangent is also odd, and the secant is even. Okay? So, knowing that, the very first thing we can do is switch these into positive angles. Is secant odd or even?
Even.
Which means the secant of pi over 12 is the same as the secant of negative pi over 12.
Okay.
So I can, let me erase this so that when you're following this, it'll be a little bit easier. Let's place it down below. And what about the tangent?
Tangent is negative.
So instead of in other words, if I want to replace the tangent of minus pi over 12, I got to replace it with minus the tangent of pi over 12. Okay. And I really don't want parentheses around that, do I? Because that changes the meaning of it. All right. Now, the goal on all of these is to see if you can figure out the relationship between the two primary angles they've given us here. 5 pi over 12 and pi over 12. Well, let's talk about cosine of 5 pi over 12. Now, when you're dealing in radians, like this, you got two choices. You can turn everything into degrees and solve the problem working in degrees. And of course, if the answer is 1 or -1, you're in good shape. But the better way to deal with trig, and I'm just going to tell you this as a piece of advice, is see if you can start thinking in radians.
Mm-hmm.
If you can think in radians, you're better off than translating from radians to degrees and then translating back to radians. Just stay in radians. I suppose it's a lot like learning a foreign language. They say that you've learned a foreign language when you think in that language, as opposed to trying to learn French by thinking in English and translating it to French. You think in French, and trig is similar. You're better off if you can stay with your thinking in terms of radians. What quadrant's that in?
The first?
Yeah. In other words, the most important thing for you to do to figure out these quadrants is to figure out where it fits in this picture. And 5 pi over 12 is less than pi over 2, right? Because pi over 2 is 6 pi over 12. So that is a first quadrant angle. Same with cotangent.
Okay.
Secant has been turned into pi over 12. So that's a first quadrant angle. And tangent is pi over 12, so that's a first quadrant angle. And let me go ahead and write the rest of it. Secant of 5 pi over 12. So we're dealing with nothing but first quadrant angles. Now, remember the cofunctions. So I could have said sine of theta is equal to cosine, instead of 90 degrees minus theta, pi over 2 minus theta. Because pi over 2 is 90 degrees.
Okay.
So with these cofunction relationships, you can always do this. Notice that I want to turn everything into one angle. So instead of cosine of 5 pi over 12, notice that if I subtract 5 pi over 12 from pi over 2, what do I get?
5 pi over 12 minus pi over 2?
Yeah, in other words, what we're doing is pi over 2 minus 5 pi over 12. Well, if you find a common denominator, now do the subtraction, you get pi over 12. So, I can say that cosine of 5 pi over 12 is the same as sine of pi over 12.
Okay.
Based on their cofunction property. And the only reason I turned it into sine as opposed to 1 over secant is because I realize at this point that I can turn every function here into a pi over 12 in the argument by using cofunction property.
Okay.
What should I replace that with?
Tangent?
Of what?
Pi over 12.
Okay. And how about the secant of 5 pi over 12? What can I replace that with?
Cosecant of pi over 12.
Okay. So now we have a bunch of trig functions all of the same angle. Now we can use our identities to come up with an answer. Let's put everything in terms of sine and cosine. So
Okay.
sine of pi over 12, what's this become?
Sine pi over 12 over cosine pi over 12.
Secant?
1 over cosine pi over 12.
And what does all of that become? It becomes sine squared pi over 12 over cosine squared pi over 12, right?
Mm-hmm.
Which is, we'll write it out first of all, sine squared of pi over 12 over cosine squared of pi over 12. Let's turn that into a single trig function.
Just 1.
What? Let's not yet. Let's not. Let's leave it like that for the moment. Because we don't know what this is going to turn into. In other words, we don't want to force that into tangent, which is what this is going to turn into, is tangent squared of pi over 12. Let's work with this part, wow, over here on the right.
Okay.
Let's go ahead and turn tangent into sine and cosine.
Okay. So sine pi over 12 over cosine pi over 12.
And what about cosecant?
1 over cosine pi over 12.
Cosine or sine?
Oh, sine.
Remember, there's only can be one co in that relationship.
Right.
Whether it's cofunctions or reciprocals, you don't ever want more than one co, and you always want at least one co. Okay? So that was in the numerator, so it becomes the sine of pi over 12 in the denominator. Okay, well now you can cancel that with that. And what does that give us? That gives us, well, what's the simplest way to express that? I suppose it's tangent squared of pi over 12 minus 1 over cosine is secant of pi over 12. Now, I feel like I've made an arithmetic error, and this should be secant squared, because tangent squared minus secant squared would be equal to minus 1. Remember our Pythagorean identity. Tangent squared of x plus 1 equals secant squared. So if I were to subtract secant and put the 1 on the other side, I'm going to get this. And usually these problems end up with something like that. This one did not. Which is a little puzzling. Rather than to go back through it and go from scratch to see whether we made a mistake, I would say let's go on to the next problem.
Okay.
Only because we did the critical stuff, which is to deal with odd and even functions, and to deal with, this was all about cofunctions and odd and even functions.
Okay.
And turning the angle into the same thing. And notice that it would not really have been helpful at any point in time to turn it into degrees. I'm really almost certain that I made a mistake here, and that's secant squared, which means the answer is minus 1 regardless of what anything of pi over 12 is. And that's so far been the case on every problem we've done. is that every answer has come out to either be 1 or minus 1. And the reason they're doing that is to tell you that it doesn't matter what this angle is, whether it's 5 pi over 12 or 3 pi over 12. It's still going to come out to be minus 1. I think. I don't necessarily, and didn't make a mistake, in which case the simplified, do you have answers on these?
No, not on these.
Okay. It's possible that the final answer was tangent squared of pi over 12 minus secant of pi over 12.
Okay.
Just kind of doubt it. Let's do another one, and I'll bet anything it comes out to be either 1 or minus 1.
Okay.
These things are so complicated, though, that you can see that you don't have to make but one mistake, and you're going to get the wrong answer.
Yeah, right.
You have to be perfect, and there were at least 10 steps in that problem. So attention to detail is really key, and these problems serve only one purpose. You're not going to go out there and find real-life problems that make you do these.
Right.
Just not. But what you will end up is when you practice these problems long enough, you'll get really good at your identities. You cannot confuse cosine with being the reciprocal of cosecant. You just won't. In other words, the way they get you to get good at your identities is by drilling you, and that's what this is doing. It's a drill. These are a little more sophisticated than they've been in years past. This is the first year that I've worked with Chatfield students where they are incorporating the concept of cofunctions and odd and even functions into all of the other trig identities. Let's do another one.
Okay. I have the secant of 400, and then 400 is in parentheses. Cosine of 310, and 310 is in parentheses. Sine, parentheses, 140. Cosecant, parentheses, 50. Minus cotangent of parentheses, negative 50.
How many terms are we going to have after the minus sign?
Just 2.
Minus cotan? Of what? 50?
Yeah, in parentheses, negative 50.
Negative 50, okay.
And then tan, in parentheses, negative 40.
Okay. Now the first thing we're going to want to try to do here is turn everything into the same angle. It's awful hard to work with these when we have 3 different angles. So what can we do here? What's the equivalent of secant of 400?
Cosecant of...
Start with the fact that 400 is outside the unit circle. We want to get it inside. How do you get an angle to be inside the unit circle?
Subtract 360.
Subtract as many multiples of 360 as you need to. Well, you only need to subtract one of them here. So this is the same as the secant of 40. Well, I see a 40 over here. I see 50s, which I can use cofunction to turn into a 40. So it looks like 40 might be the secret answer. Okay. So how can we turn in some of these into 40s? Well, let's look at cosine of 310. What quadrant is that in?
The 4th.
Okay. And it's positive, right?
Yes.
What's the equivalent first quadrant angle? In other words, if I wanted to write that as a first quadrant angle, what angle would it be?
40?
Yeah. cosine of 40. In other words, the cosine of 310 is the same as the cosine of 40. Notice that 310 goes all the way around this way, leaving a remaining angle of minus 40, but the cosine of minus 40 is the same as the cosine of 40. So I can replace that with the cosine of 40. Well, now I can see that 40 is definitely going to be my key angle. What can I replace that with to try to come up with 40?
It's just sine 40.
Yeah, in other words, the sine of 40 is the first quadrant angle that's equal to the sine of 140 because sine is positive in both the first and the second quadrant. So those two things are the same. How about cosecant of 50?
Secant of 40.
How about cotangent of minus 50?
That's minus tangent of 40.
Yeah, but I got two minuses because I got this minus here and I got that minus there. So it actually turns out to be plus tan of 40. First term, that thing does. Times tan of minus 40, which is the same as minus tan of 40. So I can go back and put the minus sign back in there and make it tan squared of 40. Okay? So everything to the right of this negative sign turned out to be tan squared of 40. We now have everything in 40s. So let's see what this simplifies to. Turn it all into sines and cosines.
Okay. So 1 over cosine 40.
What's this? Secant of 40?
1 over cosine 40.
So one of these cosines takes out that, and I end up with sine of 40 over cosine of 40. What single trig function is that?
Tangent.
So now I have tan of 40 minus tan squared of 40. So I might have been wrong. On the first problem, we might have had the answer. It doesn't look like they all are going to be 1 or minus 1. Can I simplify this?
No.
Well, I could factor out a tan of 40. Is this problem in the set of problems that says just simplify, or do they want a number for an answer, or do they
It just says simplify.
Because okay, because we could use our calculator to come up with a number, but we need to. In other words, I could factor out a tan. I don't know if it does much good, but because it leaves 1 minus tan of 40, that there's no trig identity for that. Notice they're not squared. So there's no real advantage in factoring it, and that would be our answer. Put it into a calculator, figure out what the tan of 40 is. Now, it's important to realize that what that is tan of 40 times tan of 40. There is a big difference between these two statements. This, I would take 40 and square it, take the tan of that number. This, I take the tan of 40 and multiply it by the tan of 40. So that's the difference between where that 2 is. All right, the fact that we came up with this answer leads me to believe that maybe I did not make a mistake on this one, and that the proper answer is, I think, it was tangent squared pi over 12 minus secant, right? Yeah.
Mm-hmm.
And so that was our final answer. And again, you could get that number from your calculator.
Okay.
All right. We've got a few minutes left. Unfortunately, I have a 4 o'clock, so I'm going to have to leave right at 4. Do you have another one that we can do in 4 minutes? Most of these are about 15-minute problems, but...
Yeah, I have one of the find cotangent of theta if, yeah.
Okay.
So, cotangent of theta if cosine of negative theta is 5 over 11, and secant is pi over 2 minus theta in parentheses equals negative 11 square root 6 over 24.
All right. So, what can I immediately do?
Cosine will be positive. Oh, yeah.
In other words, I can say this because it's an even function. So cosine of negative theta is the same as cosine of theta.
Right.
What's the next step?
Secant and cosecant, so the cosecant will be negative.
I like the second step is to draw the triangle. Let's not even worry about what quadrant we're in yet.
Okay.
As soon as you start worrying about what quadrant you're in, you're tempted to draw it as a reference angle like that.
Okay.
I don't like that method. It's more confusing. So the first thing is to just draw a right triangle and do what? What else do we do?
Label it.
Label theta.
Right.
Because I can't label the dimensions of the triangle until I show where theta is. Theta isn't always there. Sometimes theta is up there. So now label the triangle?
Yeah. So adjacent would be 5, and then hypotenuse would be 11.
And the opposite?
6. Oh, no, that's...
First of all, you're solving a right triangle.
Yeah.
Always remember your answer starts out square root of.
Yeah, square root of 96.
So you did the square root of 11 squared minus 5 squared?
Yeah.
Okay, so that comes out to the square root of 96. And we won't worry about whether we can simplify that. We can, because 4 goes into that. In fact, so does 16. 16 is a factor of that. Now let's go ahead and simplify it. That's 16 times 6. So that's 4 root 6.
Okay.
All right. Now let's go up to this information there. What can I substitute for secant of pi over 2 minus theta?
Cosecant equals negative 11 root 6 over 24.
Cosecant of theta equals negative 11 root 6 over 24. Now let's figure out the quadrant we're in.
All right. So cosine is positive in the first and the fourth, and then sine. So the first one.
All trig functions are positive in the first quadrant.
Mm-hmm. Oh, it's negative. Okay.
So where is the cosine positive and the sine negative?
The fourth.
Okay. In other words, these two pieces of information will always specifically tell you which quadrant. It's never going to be ambiguous. Okay, so now what's the cotangent of theta equal to? What's the absolute value of it, first of all?
5 over 4 root 6. And then...
What is its plus or minus sign?
So that's negative.
Okay, and then rationalize that.
So 5 root 6 over 24.
And there's your answer.
All right.
That's really how you do all of those. The only extra thing this had in it was they gave you the cofunction.
Right.
Another trig function. All right, Emma. Have a good week. I will
Okay, thank you.
talk to you next time.
All right.
Bye-bye.